Now, the relational model uses tables, but also uses table relationships. I want you to see here we have the products table and the categories table. Now, in the original products table I had a category column. And think of how many repeating items we would have. We might have 1,000 products, but only 10 categories. So you'd have a lot of repetitive information in the products table. You also are going to have a problem when it comes to wanting to obtain more granular information about categories. So if you want to what's called normalize your data, one of the chief rules of normalization is to get rid of repeating data and break that data out into a separate table. I've done that, and I've created a table called categories that tracks the category name, and of course we have our cat ID primary key field that uniquely identifies each row in the table. And what's cool is by using constraints, you'll see the SQL code in my upcoming demo. The great benefit of that is twofold. One, we can reduce data redundancy and having to introduce the possibility of a user error. I mean, what if a user put in a category in the products table that didn't actually exist in the categories table? When you create a relationship, which in effect involves a link between the category column in the products table and the categories table cat ID column, you can easily ensure what's called referential integrity, such that you would always have checks against invalid categories being added to the products table. And as the code below shows you, you can write select statements to query data transparently across multiple tables. Isn't that awesome?